Two mysterious objects are crossing the solar system at this very moment. For the scientific community, the simultaneity of these phenomena is hardly the work of fate. What if the simultaneous arrival of the enigmatic comet C-2026A1 and the interstellar object 3I Atlas, with its 22 unexplained anomalies, is not a mere coincidence? Could we be facing a message that humanity is not yet able to process? While Harvard's chief astrophysicist raises this hypothesis, time is running out. On April 4, 2026, C-2026A1 will defy the laws of physics by crossing the solar corona at an impressive 557 kilometers per second. But before we begin, don't forget to like and subscribe to our channel. The Sun is about to reveal the true nature of this object. Discreetly detected by the Amex-1 Observatory in Chile, MAPS C-2026A1 is not what it seems. Although initially mistaken for fragments of the Kreutz group, its orbital period of 1,800 years, twice that of any known comet in this family, proves that it is an unprecedented anomaly. It was detected 81 days before perihelion at a distance of more than 299 million kilometers from the Sun. No previously known Kreutz group comet has ever been observed so far away and so early. This type of early detection at this distance suggests an unusual size or extraordinary gas release activity, neither of which corresponds to the standard profile of the Kreutz group. And then there's the brightness. C-2026A1 currently has a magnitude of around 9, dramatically brighter than models predicted for this stage of its approach. There is no satisfactory conventional explanation for why it is becoming so bright so early. Its orbital inclination is 144.5 degrees. For comparison, 3I Atlas has an orbital inclination of 175.1 degrees. That's a difference of 30.6 degrees, close enough to raise suspicions, but too far to confirm any direct relationship. Loeb himself analyzed the possibility that C-2026A1 is a fragment that broke off from Atlas 3I and ended up captured in an orbit bound to the Sun. His conclusion is that it probably isn't. The difference in size and inclination makes a direct connection unlikely. But there is something he doesn't rule out. C-2026A1 may belong to a still unknown group of comets, objects gravitationally bound to the Sun, but which follow orbital trajectories that do not correspond to any already cataloged family. It may represent a completely new class of objects in the solar system, and the fact that it appeared in our skies a few months after Atlas 3I, coming from a broadly similar region of the sky, is a coincidence that serious scientists aren't immediately dismissing. Now let's talk about what happens on April 4th, because this is where things get really remarkable. When C-2026A1 passes through the solar corona, the heat will be extreme. Any solid surface will begin to vaporize. And this vaporization is actually an opportunity because it exposes the object's internal composition in a way that is impossible to observe under normal conditions. Inouye Solar Telescope in Hawaii and the SOHO spacecraft will be observing. What they find in this cloud of superheated gas may tell us more about the true origin of C-2026A1 than months of traditional observation ever could. From Earth, we will be able to follow this in real time through the LASCO coronagraph on the SOHO satellite. The comet enters the wide field of view on April 2nd and orbits the Sun on April 4th and, if it survives, exits the narrow field camera around 1 a.m. Eastern Time on April 6th. Nobody knows if it will survive. French optical engineer Nicolas Lefaudeux modeled 4 possible outcomes. In the worst-case scenario, the comet fragments before even entering the Sun's field of view, just as happened with Comet Ison in 2013. In the best-case scenario, it reappears on April 7th with a tail extending 10 to 30 degrees across the sky, potentially the most spectacular comet visible from Earth in decades, bright enough to be seen with the naked eye. low in the western sky after sunset. The James Webb Space Telescope captured images of this object on February 7th in 2026, offering one of the first detailed analyses of its behavior. From these observations, researchers estimated that the nucleus is about 400 meters long, comparable to the length of 4 city blocks lined up. In practical terms, it is a relatively small object by cosmic standards, but still significant enough to generate intense phenomena. This size is reminiscent of Comet Lovejoy, which in 2011 survived an extremely close passage to the Sun and ended up becoming, for a brief period, visible to the naked eye in various parts of the world. This shows that the survival of a comet under these conditions is not impossible. However, researcher Chi-Chung Zhang, responsible for leading the analysis with Webb data, highlighted a detail that is noteworthy. C-26A1 is releasing gases at an unusually high level. These jets of material, composed mainly of rapidly sublimating ice, act as small natural thrusters capable of altering the rotation of the nucleus. In extreme cases, this effect can cause the comet to spin uncontrollably, like an accelerated top, until it reaches a breaking point and fragments before even getting closer to the Sun. At the same time, amateur astronomer Michael Yeager observed another unusual behavior. This comet is producing very little dust, and this is particularly strange because it is precisely the dust-reflecting sunlight that usually creates those bright and spectacular tails that we associate with comets. Without this dust, the object can remain relatively inconspicuous, even while being active. There are several hypotheses to explain this behavior, but none of them completely solves the enigma. One possibility is that the nucleus has developed a more rigid surface crust, capable of trapping dust while allowing the release of gases through internal fissures. Another hypothesis is that it is a comet extremely rich in volatile compounds, which would have already lost a good part of its solid material over time, leaving mainly gases, which would indicate an object in an advanced stage of decay. Still, both explanations leave important gaps. That's precisely why the next few weeks are so critical, not just for astronomy, but for anyone interested in better understanding the origin of these cosmic visitors. If C-26A1 survives its approach, scientists will be able to obtain a kind of chemical fingerprint of its interior by analyzing the gases released. This will allow them to identify its composition, infer the region where it likely formed, and verify whether it shares characteristics with typical objects in our solar system or shows signs of something more unusual. On the other hand, if it doesn't resist, the disintegration process itself will be extremely revealing. The way the nucleus fragments can indicate its internal structure, the cohesion of the material, and even its formation history. In both scenarios, valuable science is being produced in real time. Therefore, April 4th is not just another date on the calendar. It's a potentially decisive observation point for better understanding not only this comet, but also the process that shape objects coming from the most remote regions of space. We are living through an extraordinary moment in the history of solar system science. In less than 12 months, we've had the most anomalous interstellar object ever recorded pass through our backyard. And now, a comet that doesn't fit into any known category is about to cross the solar corona at over 550,000 kilometers per hour. Definitive answers still elude scientists, but the data keeps coming in. Each new observation is a piece of a puzzle that is becoming too complex to be called mere coincidence. On April 4th, all eyes will be on the SOHO transmissions and updates from the Webb telescope. If C-26A1 emerges from the sun's glare with a 30-degree tail dominating the western horizon, you'll certainly want to be out there to see it. If this journey has sparked your curiosity, subscribe to the channel and comment. Do you think these objects are connected? Share this video with anyone who lives with their head in the stars. We are monitoring every move of this story, which, believe me, is only just beginning. You won't want to miss what happens when this comet orbits the sun.